Hi everyone, in this video we're going to finish up section 5.1 by talking about the end behavior of a polynomial function. Okay, so the end behavior of a polynomial refers to how the function behaves for really large or small values of x. So as x approaches negative infinity and infinity, how does the function, which is specifically a polynomial, behave? So the end behavior of a polynomial is actually controlled by the leading term, and the graph of the polynomial looks like the graph of the power function of that leading term. Okay, so that's what this says down here in an eloquent form. If you had a function 2x cubed plus x plus 1, this, of course, is the leading term, and the graph of that function is going to look a lot like just 2x cubed. Okay, so it'll look slightly different, and it may even have some weird behavior. But as the x value gets larger and larger, it's going to look more and more similar. Okay, it's going to have the same behavior. So, I want to determine the end behavior of this function. Okay, negative 2x cubed plus 5x squared plus x minus 4. Okay, and so you may think, well, that's quite a daunting function to graph, even if I had a graphing calculator, and that would be right. But we don't really need to graph the whole thing. We only just need to really concern ourselves with this leading term. Okay, the leading term is negative 2x cubed. And so if I drew 2x cubed, first I could draw just x cubed in red. So I'll draw x cubed in red. And so 1 cubed is 1, 2 cubed is 8 here, and then it runs off that way. It happens negative 1 cubed is negative 1, negative 2 cubed is negative 8 here, so on and so forth. And so the graph of the function y equals x cubed looks like this. Okay, that was a bad drawing. Okay, not much better, but a little bit. Okay, that's the graph of the function x cubed. Okay, when we go to negative 2x cubed, it's going to flip over the x-axis. Do that in blue. Okay, still 0, 0. But now 1 cubed is negative 2. And then negative 2 cubed is 8 times negative 2 is negative 16. Okay, and so that's off here, so it's going to happen much more quickly. Negative 1, positive 2, and then just as quickly in that direction. Even though it looks like it, the red is supposed to be slower increasing than the blue. Okay, and so this is negative 2x cubed. And so the whole function is going to imitate that behavior. And so when I'm looking for the end behavior of a function, I'm looking for how x behaves, or how the function behaves when x gets large. And in mathematics, we have a special way of interpreting or representing that fact, and that's by using limits. Okay, so I'm going to write this in terms of limits. The limit LIM, and then with a subscript or underneath it as x approaches infinity, so that's how you would read the x arrow infinity. The limit of the function as x approaches infinity, okay, is how this function is going as x increases. And so it's pretty clear that this function is going to negative infinity. It's going to negative infinity because it keeps on going downwards with no end in sight. And then consequent or otherwise, or similarly, as x approaches negative infinity, you'll see that as we go this way, x goes up, the function goes up, and up. And so the limit of the function as it approaches negative infinity is positive infinity. Okay? So that's how we can determine the end behavior of a function, okay, is to look at its leading term and then use that to make decisions about the rest. Okay? And so here I have another example, which is a little tougher. Okay? I have a polynomial that is not in the form that we want it. So we always want polynomials in standard form, which is ax to the n plus bx to the n minus 1, so on and so forth. Okay? And so we need to do a little bit of work here. To determine the leading term. Okay? And when you have something like this, excuse me, when you have a polynomial that hasn't been fully factored yet, and you try to factor it, something like x squared plus 4 cubed can really be a nightmare. But the fact of the matter is that when you multiply all this stuff out, the constants, which are here and here, don't matter at all. Okay, and so when all you're doing is trying to find the leading term of what will be the polynomial that results from all this multiplication. Okay, and so to do that, you just take everything that is attached to the x's and forget the constants. And so really we want to be considering 2x times x squared cubed. Okay, and so then we need to work with the fact that we have x squared raised to the cubed power. Okay, and that turns out that you multiply those exponents, and so you get 2x times x to the 6th power. Okay, and then you have an x and x to the 6th power that combines to be 2x to the 7th power. And so this is the leading term of the polynomial that will result from that multiplication. So we don't really need to do all the multiplication, just the stuff that goes along with the x's. Okay? And so the end behavior of that function is going to be the same as the end behavior of 2x to the 7th. And so to get an idea of what 2x to the 7th is, we just need to substitute a bunch of numbers in here. If you start with 0, 0 to the 7th power is 0, times 2 is 0. So 0, 0 is in this. Okay. 1 is 2. And then 2 raised to the 7th power is a lot. Okay. Or that it goes off this graph, definitely. And so we can go the other way. Negative 1, when you input that's negative 1 multiplied 7 times, and comes out with actually a negative, and so the other side is 1, negative 2, and then it goes down very fast. So it looks like that. Okay. So the end behavior for this function here, which we'll call f of x, is the limit of f of x as x approaches positive infinity is equal to positive infinity. Okay, it's going up, up and up and up as we go right as x approaches infinity, and as we go left and x approaches negative infinity, the function goes to negative infinity. And so there are the answers for that. So your turn. I want you to determine the end behavior of that function. Again, don't worry about the constants in there. Just worry about everything that's involved with x.